Let's see how we are going to draw the graph of y equals cosine x. We know cosine x is defined as a coordinate of x-axis. Like when the angle is pi over 3 in this case, then the x-coordinate is 1/2. Then cosine pi over 3 is 1/2. Okay, so this point is on a unit circle. Then we have a table. Pi over 3 for the angle is 1/2. Don't get confused. Here is that x value stands for angle. Stands for this one. Okay. And this x stands for this x coordinate. Radical 3 over 2 is actually the y coordinate of this point. So here x, they have two different meanings. You see x here. Here the x in this picture is the length of the arc, which is used to measure the angle. That's pi over 3, which is actually equals this part. Okay, so when x is pi over 3, then you will have a value for x coordinate, which is 1/2. Basically is from here to this point. So then you raise this line segment up to this height. Okay, so this is for pi over 3. For pi over 6, that's a smaller angle. So when x equals pi over 6, this angle, then the length of the arc is this part. The length of the arc in radian is used to measure the length, the amount of angle. Okay. So when this x is pi over 6, which is the angle value, then you will have a x coordinate is radical 3 over 2. So cosine pi over 6 is radical 3 over 2. Okay, is the x coordinate. And the x coordinate, you can see, is radical 3 over 2, which is bigger than 1/2. Okay, then the line segment from this point to the point right here, you straight it up, will be this one. X coordinate, radical 3 over 2. Actually, there is one more pointer right here when x choose 0. So 0 degrees. When x is 0 degrees is this point. Okay, the x coordinate is 1, from 0 to 1. Then we know cosine 0 is 1. Cosine 0 is 1. That's why you will have a when x is 0, the value, this x coordinate is from 0 here to the point here. Okay, so then you will have the first 3 point from 0 to pi over 6, then from then to pi over 3. Pi over 3 is twice as much as the pi over 6. Okay? Pi over 6 times 2 is pi over 3. Now, you go one more frame, then you see that will be pi over 2. Pi over 2 is 3 times as much as pi over 6. You know, pi over 6 times 3 is pi over 2. Basically, from pi over 6, you go to equal length, pi over 3, the increment is pi over 6. Then another increment is pi over 6 again. After 3 pi over 6, you reach pi over 2 for the equal amount of increment. Okay? But the y value or f of x or the length of the x coordinate is different. You see, when x is pi over 6, the length of x coordinate is radical 3 over 2. And then you move x with the equal increment pi over 6, then it goes to 1/2. Okay, this means what? This means when x moves to equal increment, the value y only moved from 1 to 1/2. Okay, it's half from 0 to 1. Okay, but for the third increment, pi over 6, the third increment, and then the y goes very fast. It goes from 1/2 here to 0, to 0, because x coordinate is 0. So you keep going. Okay, this angle is 4 pi over 6 or 2 pi over 3. Right here, you cancel 2 as a factor. So 4 divided by 2 is 2. 6 divided by 2 is 3. 4 pi over 6, which is 2 pi over 3. When the angle is this much, in a unit circle means the length of arc is this long, from 0 to here, then x coordinate is negative 1/2. You see, from 0 to negative 1/2. And then here is from 0 to negative 1/2, halfway from 0 to this point. Okay, so you may keep going like that. You will get all of the points. Okay, then it reaches 1 again. Okay, so there are 5 key points. One is the point here. This point is x is 0, y is 1. And then the second key point is x is pi over 2, y is 0. So on the x-axis. The third one is this one. X is pi degrees, y value, this y. Here is x coordinate, is negative 1. Okay, so it reaches the minimum value, -1, and then it going up, hit the fourth key point, okay, when x is 3 pi over 2, x coordinate is 0, okay, that's for cosine, and then it reaches the last one. That will be when x is 2 pi, then you will have a cosine 2 pi is 1. X coordinate is defined as cosine in the unit circle. Okay, here is x coordinate is the length of arc or the angle, the amount of angle. You see here is red part, and here is also red part. When you move back, you see here is red part, here up to this far is red part. It basically says that this length from 0 to 11 pi over 6 equals the arc length starting from here to here. They are equal. Okay, so you can see down here from 0 to pi over 2, cosine x completes one period. It can move from this point again one more circle. Okay, previously we did is from 0 to 2 pi, but you can also rotate like this, clockwise direction. So you will get another part on this graph to the left. Okay. Anyway, we know here cosine x completes one period from 0 to 2 pi. So cosine x has a period 2 pi. That's one feature. Another feature is that the domain and the range. The domain, x can choose any value. Okay, you see from 0 to 2 pi, and it can go further to the right, and it can go further to the left. So the x, the domain, is all the real numbers. But range, f of x, is between -1 and +1. You see here, is in this band, -1 to +1. That's the feature for domain. Okay, and for symmetric, for the symmetric property, you can see cosine x starts with 1. 1x is 0, and it goes down in this way. On the left-hand side, it would be like this. Okay, it starts with 1, then going down to the left. So basically, it's this dotted picture right here. Okay, you see, starting from 1, then it goes down and up. So it's like a V shape. But here to the left-hand side, it's like this. So this is cosine x. Okay, you see cosine -pi over 2 is 0. It's 0. So that tells us that if a graph is symmetric with respect to y-axis, then it's going to be an even function. Cosine x is an even function, and sine x, remember, it starts from 0. That's odd function. Okay, it goes like that for sine. Okay, so sine is odd, symmetric with respect to origin. Cosine is even because it starts from 1, and then it's symmetric with respect to y-axis. So that will be an odd function. Please review this lecture. I'll see you next time.